Okay, so I want to give you a couple days to do the quiz review here. There are 21 questions on it. I'm going to make the video to go along with it, so if you need help as you're going through, you can look at my setups for any of the problems that you might be having issues with. So in number 1, we'll look at that one first. The geometric mean between 20 and 5. This is just really almost a one-step deal, really 2 steps. But we multiply 20 times 5, remember? And then we take the square root of that. So this is going to be the square root of 100, which is 10. Okay. Second one here, we want to figure out what x is. Well, we have 10, we have a perpendicular bisector. Since both of these sides are 8, I can infer that we have 5, and we have 5 here. So this is going to be a Pythagorean theorem situation for either one of those two smaller triangles. And remember, you have the hypotenuse 8, so this is going to be a subtraction deal. We're going to have 8 squared minus 5 squared. Right? Remember, when we have the hypotenuse, we're subtracting, and then we take the square root of that. So we have 64 minus 25. That's going to be 39. And then we take the square root of that, and we'll just, let's go with rounding to 1 decimal place today. So she gets 6.2 for that square root of 39. Okay. Another Pythagorean theorem deal, except this time we're going to add. We have 30 squared plus 80 squared. And then we'll need to take the square root of that. Okay, not sure what happened there, but this would be, we'll clear the screen. 30 squared was 900 plus 80 squared, which is 6400. And then we ought to be taking the square root of that, right? Remember, I started with, I lost my screen here, 30 squared plus 80 squared. It's the Pythagorean theorem. And then I'll take the square root of that. So this is going to be the square root of 7300. So I add those together. So when I take the square root of 7300, I get 85.4. That's 85.4. Okay, so now we need another Pythagorean theorem. And again, we see we have 24 here, so we're going to have to infer that that's 12. So I have the hypotenuse, it's 24. So that would be by itself on the Pythagorean equation, which means we'll subtract. So I would have to do 24 squared minus 12 squared. And then take the square root of that. So that's 576, that's 24 squared, minus 144. And I get 432 under the radical. And we take the square root of that. 20.8. Okay, x equals 20.8. So here we have to, we can possibly eliminate some answers that I wouldn't bother to try here. 17 plus 7 is 24, so that can't even be a triangle. Okay, so I won't even bother to try that one. So what I need in order for it to be a right triangle, remember we did acute, obtuse, and right with this rule. I need the two smaller sides, which in the case of the first one would be 3/4 squared plus 1 squared would have to equal 5/4 squared. Okay, so you're going to have to work a little bit with some fractions here. This is going to be 9/16, or you could just use your calculator. Plus 1 equals 25/16. Now, you could use your calculator, or remember that 1 is really 16 over 16. So really what this is saying is 9/16 plus 16 out of 16, that's 1. Does that equal 25 out of 16? And I think you'll find that indeed it does, because 9 plus 16 is 25. So that is our guy. That's our right triangle there. I don't need to bother to try with the other ones. Okay, another solve for x. This is going to be Pythagorean theorem again. We can assume that we have 4 and 4 here, since 6 and 6 are equal to each other. And this is one where we would have to subtract 6 squared minus 4 squared. That is going to equal x squared, right? Because this would be 4 squared plus x squared equals 6 squared. 6 is the hypotenuse. So we have 36 minus 16. So not sure if that recorded a moment ago, but we have 6 squared minus 4 squared. It's 36 minus 16, which is 20. And we take the square root of 20, which is 4.5. Okay, so the next one's a little tricky. I'll find x in the first one and y in the second one. I have to be able to picture that I have two similar triangles here. I don't know if you can see, but if you see this little triangle here with 90 degrees, okay, it's a right angle. It shares this angle over here with the whole triangle. See how we have 8 and 3 is 11 on a hypotenuse? So if I look at the hypotenuse of this smaller triangle, I'm looking at this one, right? X is the hypotenuse, 3 is the short side. Now look at the big triangle. It's this whole thing here, okay? X was the hypotenuse in the small triangle. What's the hypotenuse in the big triangle? It's 11, okay? 3 was the short side in this little triangle. What's the short side in the big triangle? It's x. So you kind of get a geometric mean setting here. We get, when we cross multiply, we get x times x, which is x squared, equals 33. And this is what we've been doing the whole chapter. So we take the square root of 33 to get x. Okay, so the square root of 33 is 5.7. Okay, a little bit trickier setup than what we're used to. Now I do the same thing in the next one. Notice I have my little triangle here, and then I have the big triangle. Those are the two that I'm going to be dealing with. So let's make it real simple. In the little triangle, we have the side, 4, over the hypotenuse, which is 6. So now let's go to the big triangle. What's the hypotenuse in the big triangle? 4 plus y. It's a little bit trickier setup. Okay? And then what's the smaller side in the big triangle? It's now 6. So similar in the big triangle, I mean this one, and then here's the small side, 6. Okay? So now when I cross multiply, watch, we had this last chapter, make sure that 4 gets multiplied by both of those. So you would have 16 plus 4y. Some of you are going to have bad memories about forgetting to multiply by both of those, right? 4 times 4, 4 times y. 4 times 4, 4 times y. Okay, 6 times 6 is 36. And we subtract 16. So I get 4y equals 20. And then divide by 4. So in that case, y equals 5. So we already got x. And then there's y is 5. Okay, so remember what's going to happen here. We're going to take 20 squared. We're going to add that to 30 squared. And then we're going to compare that to 40 squared. If this is an equal sign in here, if that question mark is an equal sign, it's a right triangle. If that question mark is a less than sign, if these two things added together are less than 40 squared, it's an acute triangle. I'm sorry, obtuse. If this 40 squared is so big that it's bigger than both of these combined, that's an obtuse triangle. And if these two, that kind of makes sense, the two teaming up together should be bigger than the 40, we'd have an acute triangle. So I have 400 plus 900, and then I have 1600. So 1300 and 1600. Okay, 1300 is less than 1600, so what happens here is that 1600 is so big, right? Here's one side, here's another side, but then that third side is so much bigger than those two even combined, so that would make it an obtuse triangle. Okay, and pretty much the rest of the way here we're simplifying radicals. So if you remember, I want to get the largest perfect square that divides into this. So I have 200. I'm going to break that into 100, which is the largest perfect square that will divide into it, and then just 2. So the 100 is a perfect square. We take the square root of that and leave the radical 2 underneath there. Okay, 90. Okay, right away we can probably see that 9 goes into 90. So let's give that a shot. What if we had the square root of 9 times the square root of 10? And I think I can see right away 10 is not going to break down for me, so it looks like I have what I want with 3 square root of 10 under there. Okay, 9 goes into 18 as well. Let's use it again. Square root of 9 times square root of 2. 3 square root of 2. So again, let's think about the biggest perfect square that goes into 32 would be 16. 16 times 2 would be 4 root 2. Okay. Square root of 12. Biggest perfect square you're going to get to go into that is 4. Square root of 4, square root of 3. 2 root 3. 75, biggest perfect square, we've seen this a number of times, would be 25. Square root of 3. So they still multiply back out to be 75. So this would simplify to just be 5 square root of 3. Square root of 45, we have square root of 9 times square root of 5. 3 root 5. Okay, square root of 120. Okay, let's think about this for a second. We know 4 would go into it, right? And what happens when 4 goes into 120? The square root of 4, let's just look at what's left under it. If we can't think of any other perfect squares that live under what's left, 30, and we've seen 30 get stuck under that radical before. The only numbers that go into it are 15 and 2. No perfect squares. That's just prime factorization, 3, 5, 2. And none of those are a 4, so 30 is going to be stuck there. We're going to have 2 square root of 30 for that. Okay. Square root of 28, another one that 4 goes into. Right away we can see that. So we have square root of 4, square root of 7. 2 root 7. Okay. That's 2 here. We have 36 goes into 72. If you tried 9, it's not going to be big enough. 36 times 2 is the one that we're going to want there. So that's going to be 6 square root of 2 left under there. 150, 25 again goes into that. 25 times 6. So square root of 25 is 5, and the 6 will have to stay under the radical. Okay. 128. Have to go a little bit bigger for this, but 64. If you just do 4, it's not going to be big enough. There's going to be other numbers that live inside that. You'll get 32. So if we try for 64 here right away, it goes into 128 2 times. So I simplify this to 8 square root 2.